Hey, Jonathan here at Colfax Math. In this video I'm going to go over accurate measurement to the 16th on a steel rule, to the 32nd, and then to thousandths of an inch on a dial caliper.
Measure the height. Measure the width from here to here.
Laminated overnight on a CNC cut jig.
So let's start with the steel rule. This is a steel rule from Harbor Freight. It's actually a really nice rule, really easy to see. Before you even use a rule, you want to figure out the increments that it's measuring at. You can see here from the 1 on, there's 1/16 of an inch. It tells you that. Or you could just count them 1, 2, 3, 4. There are 4 1/4, 8, 12, 16. On the left side of the 1, we're at 32nd. So there are 32 little marks for the first inch. And you could use that for any length you want. By just measuring from the 1 over and then going to the left to be accurate to a 32nd. So most woodworking is accurate to 32nd or 16th. Metalwork, pretty similar depending on what you're doing. But then after that fractional measurement of a 32nd, then you go to the dial caliper. So let's say I wanted to measure the diameter of this circle. I know the diameter is going to be the longest length. So I'm going to move this. And I could see it's a little bit under 2.5, but I can't exactly tell how much under 2.5. So there's 2.5. So what I'm going to do instead is I'm going to come down to the 3, start right at 3 there, and then I'm using the left side here. So I'm using the 32nd measurements. So I'm at 1, 2.5 minus a 32nd. So this is 2 and 15 30-seconds. So that's how you could use the 30-seconds on a steel ruler, even though they're not all the way down there. So step 1 is to learn how to measure this ruler really accurately. You should buy one of these and have one of these and use it all the time and make sure you're accurate measuring to the 32nd. Okay, from the steel ruler, we'll go to a dial caliper. This is a dial caliper right here. It's a really nice precision tool. This is inches, and then right here in the center, each little tick mark is 1/1000th of an inch. So just to give you an idea, here it's maybe 5/1000ths of an inch thick, or a piece of paper would be about 5/1000ths of an inch thick. So it's pretty accurate measurement. And the directions on this dial caliper, it says accurate to 1/1000th of an inch, but realistically it's probably more like 5/1000ths for accuracy. But that's the thickness of a paper. So for tool setup and machining, everything's done to 1/1000ths of an inch, and this tool is essential. It really incorporates a lot of really big math ideas, one of which is this idea of rotary motion, converting from rotary motion to straight motion. It's kind of an angular versus linear velocity. So every revolution on this thing, if you watch, going around, every revolution is only 1/10 of an inch. And you can see that right there. So there's a 1, a 2, a 3. As I keep going around, I go around 10 times. And once I'm around 10 times, I come to an inch. So even though we're using inches, it is kind of a base 10 number system with this dial caliper. So this is 1.1, and then that's the tenths place right there, the hundredths and thousandths place. Okay, before I go over all that though, let me get started. So the first thing you do with this tool is you treat it very gently. It is a precision instrument, and it'll only stay a precision instrument if you treat it well. The first thing you do with the dial caliper is you close it gently, and then you zero it out. So this is a set screw here, and you can move this thing around to zero it. So once it's closed gently, you bring it right to 0, and then you tighten up that. These are the jaws right here. This is for an outside dimension right here. This is for an inside dimension here. On the end of this is for the depth, and you can also measure a step using this part right here. So that'll measure the depth of a step. If you want to lock it in place, this is a set screw so that it won't move. And then this is a thumb screw that you can move it on. And I don't know if you could see right here, there's a gear inside of there that runs on that rack right there. Okay, so how this thing works is you have to use the bar as well for the number, then the tens place, hundreds, and thousands place. So let's say now I'm measuring the circle here. Open it all the way up. Outside dimension there. The largest one is 2 point. It looks like a 5 right there, but it's actually right before the 5. And the way I know it's right before the 5 is because this dial is right before the 5. So this is 2.489. So the diameter, outside diameter, is 2.489. Let's go to another measurement here. I'll just make sure you're reading this correctly. So this is 1.000, 1 and 0 1/1000ths. Right? And you talk about it, you include that as significant figures. So that's 1.000, accurate to the thousandths of an inch. This right here, so let me start at the 1. This is 1. I'm just going to go back past by 10 thou. So this is 1.010. I'm going to do a full revolution around. And I can see the 1.112 because I'm at 12. Right here, I'm at 1.200. So if I just move it randomly to some place like right here, and I look on that bar, I can see I'm at 0.653. So this measurement right here is 0.653. Tell me what this measurement right here is. This measurement is 1.567. So here's my 1 full inch, my tens place 5, 6, 7. I could see the 6, but I'm not quite at the 6. And you'll watch as this dial gets close to 0, then you'll see the line of the 6. Okay, let me do a little more here. So you can measure a thickness right here. See how you could almost see the line of the 2? The line of the 2 is after it, so that's the 2 right there. So I could tell I'm not quite at the 2. So this is 0.187. Gently closing in the jaws. Then could use inside diameters. I could open this up here. And I can see I'm almost at the 1, but I'm not quite at the mark at the 1. So this is 0.970. That's 0.970. If I want to find the depth of something, let's see if I could do this. I take this bottom piece out here, bring it right in there. See how that's finding the depth? And that's going to be, I'm almost at the line after the 3, so I'm at 0.298. So that's 0.298. And then if I want to find a step, do it kind of the same way. Measurement right there. Alright, let's just do a few more, see if you can figure these out. The one thing that throws people off is they see the number, so they think it's after the number, but the mark for the number for the tens place is after the number, right? So this right here, this measurement here is 0.525. But even though now I could see the 6, I haven't got to the line of the 6, so this is 0.579. Go all the way down here. Tell me what measurement that is. So that is 1.832. We go all the way down here, say to this measurement there. I could see a 6, but I haven't got to the line of the 6, so this is 2 2.570. See, I'm just past that line, 3.114. Thank you for watching. This is Jonathan at Colfax Math, all math and applications of math. I hope that helped you with the dial caliper. You could buy these at Harbor Freight for really very little and play with them and just keep using them. The way to get good at these things is to use them. So thank you for watching. I'd love to hear your comments below. Learn how to measure well. It'll really help in any job or any build or any math class. It's the foundation. So comment below. If you like the video, please hit like and subscribe. It's Colfax Math.